Okay, so this presentation is Science to Management, Introducing the Stewardship Program at the Wells Reserve. Science to Management, if that term's not familiar to you, that's sort of the heart of what the reserve system is all about. And the reserves, it's not just us, there are 29 reserves. I think it's 29 now throughout the country. And our primary mission is to generate and communicate science to our communities and the decision makers within our communities so that they can make informed resource management decisions. And so our reserve system is comprised of primarily of three sectors: our research, education, and stewardship sectors. So today I'm going to be focusing primarily on stewardship. However, my caveat is that there are very blurry lines between these sectors, and all of us cross over those lines all the time in order to do the work that we do. So my background actually is in the research department, but over the years I have stepped further and further into the stewardship and resource management world, and that's where I find myself sort of firmly in place now. So you all are familiar with where the reserve is located here in Southern Maine. This is just a map that I pulled from a recent planning document that we put together, but it's essentially a watershed map of the three watersheds that that feed the estuaries at the reserve. We have the Little River, Maryland, and Branch Brook. That's the northernmost purple bounded area. Then we have the Webhanet River in the middle and the Kennebunkport River to the south. And that green highlighted polygon that you see along the coast, that's the reserve's boundary. So all of the land within that area, the land and the water within that area, is part of the Wells National Estuarine Research Reserve. It's also part of the Rachel Carson National Wildlife Refuge for the most part, especially the marshes, and a number of other entities, including the state and the town. So the Wells Reserve has a number of different partners that own the land. And then, of course, our Lot Home Trust, which owns the farmhouses and the small area around the campus. So our stewardship and research management program has three overarching objectives. The first is to manage habitat in a sustainable way for biodiversity and ecosystem functions, while providing opportunities for education, research, and public use. The second is to use a watershed approach for our stewardship and land use, and that's a holistic approach that takes into account all of the ways that that human beings are affecting those water resources. So we look outside the reserve boundaries at a watershed scale. And the last is to provide technical assistance and expertise to our coastal communities as they work to manage their resources through conservation, restoration, and species and habitat management. And the reserve works closely with a number of agencies and nonprofit organizations within the state, as well as municipalities. These are the core groups that we work with, and they comprise primarily resource management agencies. And you'll see also on the list the town of Wells, who we work very closely with. Maine Department of Inland Fisheries and Wildlife. We have members of these organizations that sit on our advisory boards, that come to our site and actively manage for species. We typically are consulting with these agencies whenever we're undertaking some type of manipulative resource management activity, like invasive plant removal. So anytime we have questions or we want to work on some part of our reserve that involves these habitats or these species, we're often reaching out to these organizations. And this is a little bit fuzzy. I took it from a lower resolution map, but this is just an overview of the primary habitat types within the reserve boundary. So we have open upland, forest, salt marsh, and subtidal. And within those basic categories, there are other categories of habitat, but that's just sort of gives you a general breakdown. So as you can see, most of the reserve is salt marsh. And this is the Webb Hannet is one of the largest, I think maybe even the largest contiguous salt marsh in the state of Maine. And we do also have some areas within the reserve that are upland, which are buffer areas that we've conserved to help protect the salt marshes. And again, a lot of this area is already conserved as part of the Rachel Carson National Wildlife Refuge. I won't get into the sort of legal legislative background about why we sort of coexist with the refuge, but let's just say that they're really the managers of that habitat, but we work with them to study the salt marsh, and we do actually work with them to even manipulate it sometimes for management purposes. This looks pretty lengthy, so I'm not gonna read this verbatim, but we have a couple of different management zones within the reserve, and so that's a good way to think about how what our approach to resource management looks like here. We have different areas, and within those areas, there's different management and stewardship approaches. So within our active management zone, I'd say that's where we're doing the most, sort of activity to manipulate habitat or to manage certain species or to control invasive plants. So those are the types of activities that are taking place in those areas. This is typically our fields and to some extent our shrublands that border those fields. And in those areas are areas that were historically farm fields, and we are actively maintaining them as fields so that they don't convert to early successional forest and ultimately more mature forest habitat. And the reason that we're doing that is because there are certain types of species, birds, plants, mammals that are endemic to that type of habitat. And we want to make sure that the reserve can maintain a diversity of species and diversity of habitats. And so we're maintaining those fields as fields, into the future. A lot of the work to do that involves mowing. So we have a field or a grassland management plan that we use to guide our activities there. We typically mow these fields. We could mow them probably every year, but we have such a large area that we're typically doing that every other year or so. We can't let it go too much longer than that because then the small shrubs start to grow up and get larger, and then it becomes harder and harder to control them. You have to get in there and actually manual cut rather than mow them. So mowing is an activity that you'll see at the reserve happening a lot of the time. We try to make that that activity as harmless as possible. So in recent years, we've actually started mowing after a certain point in the summer when most of our grassland birds have already fledged their nests, and those birds have moved on, or they can more easily get out of the way of the mower. We also have been, with the help of the education department, we've been mounting a monarch butterfly rescue to remove monarch chrysalises from the milkweed that grows in the field, so that we can make sure that those, that those butterflies are surviving. And so typically that's taking place at the end of the summer or the fall. We have some fringe areas on the marsh, on the reserve along our grasslands where we're allowing early successional habitat to start growing up. And so we've been actually actively planting in those areas, shrub species such as alders, hazelnut, and other early successional shrubs and trees. And that's been part of an ongoing project for the last 13 years to restore the New England cottontail rabbit to the reserve. And we've been working closely with a number of different organizations, including U.S. Fish and Wildlife Service and the Natural Resource Conservation Service, which is part of USDA. And we've received a grant to, over time, improve habitat for this species. And we're actually reaching the end of that. We're probably in our final year. We're going to be doing some more shrub plantings this fall and some invasive species removal, pulling out bittersweet and barberry that's growing up in those areas. It's interesting. So this is one of the projects that I've been aware of since I've been here, but I'm learning a lot more about it now as I'm jumping in. And um, we do have New England cottontail living here on the reserve, and they're actually, it sounds like they're doing pretty well. And they don't know that we have little boundaries drawn around our habitat around the reserve, and so they move around where they like to. And so we've actually been finding them in some of the areas where we had intended to do invasive plant removal this year. So we're actually going to have a meeting with the NRCS folks later this week to talk about how we can complete the grant, because they want to close out this grant. They want to give us our money for all the activities that we've been doing, but we have to kind of negotiate that because we don't want to go in and start cutting down the barberry and the bittersweet and all that stuff if the rabbits are actually using that area, because obviously that would be disturbing for them, and they might move on. And so anyway, so it's a bit nuanced, but those are the basic activities that we're involved with there. Our conservation zone is basically just that. It's an area that, or they're areas that we essentially leave more or less untouched. This is primarily our forests and some of our shrublands and our freshwater maple wetlands. We do a little bit of cutting in these areas just to kind of maintain public access and public safety, cutting along our trails, obviously. But other than that, we basically leave these areas alone. And these, you'll see this in the parentheses here, this word buffer on both the active management zone and the conservation zone. These buffers, these are still natural areas that we're maintaining for one reason or another, but they're natural areas and they're surrounding what we call our core areas, which I'll get to in a moment. And these buffers are very important because they provide protection to those core areas that are more sensitive to pollution from runoff primarily, but also from human activity. And so we maintain these buffers in order to protect the more sensitive areas of the reserve. And that brings me to the protected zones. This is our core area that the reserve manages. These are the areas that are in need of most protection. And so again, getting back to that idea of buffering them with other habitat types, this is typically our salt marshes, our freshwater wetlands, tidal channels, and our beaches and our dunes. And these are locations where we have highly sensitive species. They're highly adapted to these environments, and they don't tolerate change very well. And in particular, we have a couple of species that are federally listed. So we have piping plovers that inhabit our Lodholm Beach on a seasonal basis. That's a federally endangered species. We have least terns and red knots. I believe those are both endangered as well. And we work with U.S. Fish and Wildlife Service to make sure that the areas that those birds are using are actively managed to keep people and predators out. So if you come down to Lodholm Beach now, if you walk down to the little river, you'll actually see a big roped off area with signs, and that's where the piping plovers are nesting currently. We have a number of nests in that area this year. And you'll actually notice that on top of the signs, there are spikes sticking up. And what U.S. Fish and Wildlife recently found is that owls have been coming down and perching on top of those signs. So something we have to really watch out for with the New England cottontail as well, managing predator perches in the vicinities that we're managing these animals, because those birds just sit up there patiently waiting for one of these little cute little piping plovers to poke its head out of the dune grass, and then they pounce on them. Predators are not the only thing that we have to be concerned with down there. Human beings are another concern. People don't respect these ropes. Their dogs certainly don't respect these ropes. So we have volunteers that are down on the beaches throughout the nesting season, educating people and hopefully helping to make sure that they're not going in and disturbing those areas and chasing the piping plovers around on the beach. It's a lot of work. This species management work is really intensive. It requires a lot of help, both from volunteers and from the agencies. I'll be honest to say that reserve staff don't actually spend a lot of time on this. We're more liaisons as the landowners. But obviously the reserve itself is a very important place because it's home to these special species. And so, we're really happy to be working with these partner organizations to make sure that they're conserved. And as you can imagine, these areas are really not open to the public for the most part. We do bring people in through our educational programs, as well as through our research and stewardship activities. We're a site of great interest for visiting researchers. And so part of our mission is to support research by external institutions. And so we spend a lot of time working with these folks to make sure that the research that they're doing is not going to be impacting the species and habitats that we're trying to protect, and also hopefully answering questions that we'd like to see answered related to their conservation and their status. So that's our zones. That's kind of our big picture. How do we look at the reserve in terms of what activities we're concentrating on in our stewardship department? And now I'm just going to break that down a little bit into some of the activities that we're involved with, or we have been involved with over the years. So in our resource management efforts, the first thing I'll talk about is our disaster response plan. And when I say disaster response, you're probably thinking, like evacuations and public safety. But really, when we're talking about disaster response, we're thinking about how is a natural disaster or a man-made disaster going to impact our natural resources at the reserve, and what type of contingencies do we need to have in order to protect those resources. So we put together a disaster management plan a few years back, and it includes all kinds of information about the sensitive areas of the reserve and how they might be affected by disasters like like an oil spill or a hurricane. Everything from man-made environmental disasters all the way up to natural disasters. We have a deer population control program. The reserve is home to numerous white-tailed deer, and they browse heavily on the vegetation. They also spread deer ticks all over the place, and they're really, they would run wild and get quickly out of control if we weren't managing them. So this is one of the maybe less popular things that we do at the reserve, but it's something that's definitely necessary. So fortunately, we work with some local hunters who they use bow hunting. So we don't have gun hunting on the reserve. So you won't hear gunshots ringing out from our woods, but you will see signs from November through January that indicate that a deer hunt is going on, and that's really just our effort to keep those populations from exploding. We definitely are not removing all of the deer from the reserve. In fact, not even close. I don't remember what the exact count is, but I think it's somewhere in like, a dozen per year or so. And there's definitely many, many more deer on the reserve than that. So you'll still find white-tailed deer in our fields at dusk and at dawn. They're definitely part of the reserve, but we really have to make sure that their population doesn't get out of control, because of course we don't have any of the natural predators left that would control them normally. So we would have had mountain lion and gray wolf and coyotes to a certain extent that could control the deer. We don't really have them anymore. We do have some coyotes living on the reserve, which is pretty cool. You can hear them from time to time. The next activity that we're involved with is our invasive plant control. We have a number of exotic plant species that have run rampant throughout the reserve. And if you ever walk our trails, particularly on the eastern end of the reserve along the boardwalks, you'll definitely see Japanese barberry and honeysuckle all over the place. And there's not much that can be done about it at this point, except to try to control it in those areas that are most important. And so we have an invasive plant control plan that does just that. It identifies those places where it's most important to keep those species under control, and the rest of the reserve, we're essentially letting it do its thing. invasive plant control is highly labor intensive. It often requires the use of herbicides, which are, that often throws up a red flag for people. But as I'm learning, herbicide can be used very strategically and very minimally so that it doesn't negatively impact, those other species that are inhabiting those areas where those plants are being managed. And that's actually something that we're currently working on for our New England cottontail program, is to find a master sprayer. This is somebody who has been trained to apply herbicides in a relatively environmentally benign way so that we can manage large areas. And when I say large areas, I mean a half acre or more for these invasive species. And once we get those invasive species, excuse me, more or less under control, then we can go forward with some of the other types of management activities that we undertake, like planting early successional shrub species that our New England cottontails prefer, as well as moving forward with our forestry management plan in a demonstration forest that we call the Yankee Woodlot, which is adjacent to our dormitory, if you're not familiar with where that is. The Yankee Woodlot was sustainably harvested in, I want to say 2013 or 2014. And we hired a forester to develop a forestry management plan for that area. And essentially this is meant to demonstrate to small woodlot owners how their woodlots can be sustainably managed without clear cutting, to promote sustainable growth of quality tree species that can produce good lumber, and also support wildlife. And so we're coming on 6 or 7 years now since we made that initial cut. We've had a couple of invasive plant control campaigns in that time, and but it's been a while, and some of those plants are now starting to get out of control again. And before we can get in there and really do any of the next steps in our forestry plan, we need to get the invasives under control. So that's another piece of that invasive plant control, is finding somebody that can apply those herbicides, and we're hoping to move forward with that this year. And if you know anybody, let me know. Okay, moving on. So our open field management, I already talked about that. I won't go over that again. Our forest management, I sort of just talked about that. So the last piece here is kind of, I think, one of the more exciting parts, and it's some of the newer stuff that we're doing. My predecessor, who's still at the reserve, and some of you folks probably know, Sue Bickford, has really been responsible for introducing the use of unmanned aerial systems to the reserve, drones, if you will. And so here we have just a stock photo here of one of the drones that we use at the reserve. This is made by a company called DJI. And you may have heard in the last year with the previous administration that these drones were banned for use by federal agencies because they're made in China. And there was some concern that they might be somehow used for spying remotely. I'm not sure exactly what the concern was, but anyway, that's no longer the case. So we never had that limitation, but some of our partners were not allowed to fly these drones. Anyway, we're back up and running now, and we're working with some of our National Estuarine Research Reserve partners to explore the use of these drones. And specifically this, you'll see this one is actually, it's a modified aftermarket modification to this drone. There's a small green camera that's mounted to the top of this drone. And that camera is an infrared sensor, and it allows us to collect images in the infrared spectrum. Infrared is used for monitoring vegetation, particularly for agricultural applications. And so this is not new technology. This is something that USDA and other organizations that work with farmers have been using for years and years and years. And this particular product was actually primarily engineered with that use in mind. But we can make use of it, or at least we hope we can make use of it, for monitoring vegetation in our salt marshes. And so it's something that we're working on now is trying to get out and collect data, collect this infrared imagery and use it to monitor the health of the vegetation in our salt marshes. And we also collect just regular imagery that you would see from a drone to help us map our habitat. And the image that I shared on the opening slide was actually a photo from Wells Harbor that we took with this drone. And we can just scroll back so you can see that. I'm sure you've all seen drone imagery before, but drones provide a really great opportunity to collect what we call remotely sensed data. This is aerial photography in this case, at a very high resolution. So we've had access to aerial images for decades. And typically that imagery has been collected from an airplane, which has been really great, and we've had access to relatively high resolution, a pixel. So if I were to zoom in really far on this image, eventually what we would see is just a collection of differently shaded green squares. So those individual pixels or cells are the units that we collect this data, and that's the minimum unit size. And typically with aerial imagery in the past, we've had unit sizes of, a meter, 10 meters, 30 meters. That's pretty coarse. And when you want to get down to start mapping things like how are the edges of our salt marshes changing over time? Are they eroding? Are they accreting? If we're talking about changes that are in the order of a foot or less per year, that's pretty small. For if you're going to be using coarse imagery, you're probably not going to be able to pick up those changes very well. So drones have a much higher resolution. The caveat to that is that they cover a little bit less area, or quite a bit less area than an airplane might cover at 30-meter resolution. So you really have to tailor the use of this technology to your particular questions that you're trying to answer. But suffice to say that it's an enormous improvement when we're focused on smaller areas. And so we are going to be actively working over the next couple of years to map the reserve using our drone, and hopefully that's going to help improve the research and the education pieces that the reserve is delivering. Let's skip ahead from that again. Another technology that we're using now, and I apologize, I wasn't able to come up with a good picture for these, but it's what we're calling Eco-Acoustic Ecology. And so we are monitoring with recording devices and microphones. We are monitoring the habitats of the reserve. And so we essentially put these recording devices out in different locations, and we set them to record for certain periods of time. And then we go out and we retrieve that device, and we download the audio files. And then we have a software that allows us to basically detect change in the audio signals that we're receiving. And this is another example of a project that I'm learning about. So I can't tell you much more than that. I actually have a lot of questions about it myself, but basically the idea is that we are establishing an acoustic baseline for what the acoustic landscape of our reserve looks like or sounds like. And if you can picture what the readout on your equalizer on your stereo might look like, or what wavelengths might look like, a bunch of sounds all stacked on top of each other, wind blowing, birds chirping, insects chittering, cars driving by, airplanes flying overhead, waves crashing. All that information is captured in these recordings, and we're not separating those things out individually. So we're not tracking individual species with these recordings, but we're just looking at the overall shape of the sound. And then over time, as things change, as new species appear or disappear, or new activities within those areas start taking place, we may detect changes in the overall shape of those sound files. And that's something that's being calculated using a statistical program called R. I am sort of delving into the research side of this a little bit. But anyway, so we're using eco-acoustic monitoring at the reserve, and it's also something that is being used reserve-wide. And we're working on figuring out how to incorporate it into some of the other programs that are core to what we do here at the reserves. Okay, I know this is really wide-ranging, so thanks for sticking with me. Does anybody have any questions before I go on? Okay. If not, no problem. Okay, so moving on. So that was our natural resource management, and there are a whole host of other activities that I didn't mention that are involved with natural resource management, but there's just not enough time today to talk about all that stuff. So now I'm going to talk a little bit more about what I do primarily at the reserve, which is community-based stewardship. When we say community-based stewardship, we really mean going out into the communities here in our service area, which is more or less from the Salmon Falls River to the south to Scarborough Marsh, maybe even up to Cape Elizabeth, just south of Portland to the north. And we also work inland as far as Acton, Shapley, Waterboro, and actually with the Saco River watershed, we even go further than that. So within those watersheds, we do a whole host of activities, including land conservation, species and habitat restoration, water quality monitoring and protection, land use change monitoring and mapping, GIS mapping, and aquatic organism restoration and tidal marsh restoration. So I just want to give you some examples of the types of things that we've been involved with here, and I'll try to hit each one of these things to give you a sense of what's involved. And this is the part of the presentation where I actually have some visuals. So not that this is all that exciting, but this is the cover of a document that we recently completed with partners. This is the watershed-based management plan for the Kennebunk River. And this was a 2-year effort to produce this document, but it's the culmination of decades of work by folks at the reserve, as well as folks within the watershed communities of Kennebunk, Kennebunkport, Lyman, and Arundel. The Kennebunk River also actually covers small pieces of Biddeford and Alfred as well, but they weren't really big enough to really get those towns involved. So those 4 towns that I mentioned worked with the Wells Reserve, with the York County Soil and Water Conservation District, with the Maine Department of Environmental Protection and the Maine Healthy Beaches Program, as well as a consultant that was hired to help author the document, FB Environmental. And they're a local consultant that's based out of Portland, and they work on this type of plan throughout Southern Maine at the least. They've produced watershed management plans for a number of different watersheds. And what this plan does is it essentially identifies existing water quality impairments within the Kennebunk River. That includes things like dissolved oxygen, bacteria, impaired biological communities, macroinvertebrate communities, and then it involved some special studies to go out into the watershed and try to identify potential sources that could be causing those impairments, either direct sources like agricultural runoff, or indirect sources like non-point source drainage, either from unbuffered riparian areas or developed areas in the town centers. But the idea was essentially to try to catalog all of those potential sources, and then to prioritize remediation activities or restoration activities that, if undertaken, could potentially either alleviate specific sources of contamination or over time just gradually improve conditions within the rivers and streams in the Kennebunk River, and hopefully to a measurable degree. And so some of those activities include planting more robust shoreline buffers. So a lot of times the vegetation along the edges of the river has been cut, and it's now there's particularly between Route Interstate 95 and um, Perkins Lane, if you're familiar with that, in Kennebunk. It's primarily agricultural land that's right up against the edge of the river. So we've had some concerns about manure, domestic animal waste, or agricultural animal waste that's increasing bacteria contamination. It's also without the shading of a natural canopy along there, it causes the river to heat up. And so there's temperature impairments, and that potentially also, the hotter water also potentially drives lower dissolved oxygen, all of which is not good for the critters that live in those streams. But it's also not good potentially from a public health standpoint. And the bacteria contamination is kind of the big thing that we're really trying to address with this plan. We've known for years from our monitoring that the Kennebunk River has extremely high levels of enterococci and E. coli bacteria. And those bacteria, we're not thinking of E. coli in terms of like food poisoning in this case. These bacteria are native to the guts of warm-blooded animals. So not just humans, but also cows and raccoons and geese and you name it. And so when we find high levels of those bacteria in water samples, it's an indication of fecal contamination. So the bacteria are coming out with the animal waste and entering the water. And that can then be a vector for waterborne illness, as well as as well as pharmaceuticals in the case of human sources. And so those are public health concerns. And so that's one of the major issues that we're trying to get on top of with this plan. So this is fresh off the presses as of January 2021. And the reserve, as well as these other partners, will now be working with the watershed communities on implementation of some of the recommendations that were laid out in the plan. And we've already worked with the York County Soil and Water Conservation District to submit a grant application to the Maine Department of Environmental Protection for money to start working on some of these recommendations. So hopefully we'll have more to tell you about this stuff this time next year, or maybe in 2 years when we've actually gotten on the ground and completed some of these projects. And I should mention that in addition to my involvement, we also had involvement by our stewardship coordinator, Annie Cox. And she's actually been working, this is not the only watershed plan that she's been working on. She's also working in the Kennebunkport River watershed to try to work on an implementation project there as well. That plan was produced a number of years ago, so they're in the implementation phase there. Okay, let's go back to our list here. Okay, so next up, land conservation and GIS. So this colorful little map is a land use map or a land cover map. And this was produced by our NOAA, our federal partners at NOAA, for basically to enhance the research and stewardship activities at our reserve. I don't have a legend on this. This is just a screenshot from the map, but what you're looking at, each of those colors is a different land cover type. So you can sort of see here, the blue is water. And so that big blue area in the bottom right corner is the ocean. The yellow is sand beach. So you can see kind of the shallow, the teal green is more of a mud flat or intertidal area. And then this is Wells Harbor. And this blue here is the Webhanet River. This is the jetties. And then up in here is the harbor parking lot and the town park down there. The purple, which is kind of the most prevalent color in this picture, is our emergent salt marsh. And then you have the white, which is essentially impervious surface, like rooftops and pavement, parking lots, that sort of thing. So what this map is basically it takes aerial imagery, and in this case, this was aerial imagery acquired at a lower resolution, so from an airplane. I think it was 3-meter resolution. And they use a computer algorithm that essentially takes the intensity of 3 wavelengths of light, red, green, and blue, which is the visual spectrum. when you take a photo, each one of those pixels has a value from 0 to 256. And I won't get into those numbers, but that's just the amount. It's essentially the amount of information that could be contained in an 8-bit digital format. And so you can get 256 different values of intensity for red, green, and blue. And the computer algorithm essentially groups the pixels together by how similar they are. So it doesn't know, the computer doesn't know that it's looking at salt marsh, or it doesn't know that it's looking at water or sand. It just knows how intense is the red wavelength, how intense is the green wavelength, or how intense is the blue wavelength. And so it groups pixels together based on how similar they are. And then the human beings come in and then say, okay, these categories are this type of land cover or that type of land cover. And so that's called a land use classification or a land cover classification. And then what we do, you'll see these little red, maybe you can see these little red dots all over the map. I should have picked a different color for those, but there's these little red dots. Those are points that were randomly generated for what we call ground truthing. And so we actually go out into the field, we have our habitat type list, and we go to that spot and we say, okay, what type of habitat is this actually in real life? And then we take that back and we compare that with the results that we got from the computer algorithm, and we can then train it, and we can tell it, well, this is actually salt marsh, this is actually open water, this is actually pavement. And so then we can run that land cover classification again, rerun those algorithms, this time with a little bit of help. And so that just improves the classification. So it improves the accuracy, so that it's a more useful map. So this is just an example of one of the types of GIS applications that we use. There are numerous different applications, everything from just a basic map to actually delineating specific habitat types. I don't have a good example of it right now, but in the past, we've actually gone out and mapped invasive species areas. We use GIS to track the movements of our New England cottontail rabbits. We use it for a whole host of things. So GIS is very, and I should say GIS, for those of you that don't know, stands for Geographic Information Systems. And that's just a collection of spatial data, so data that is associated with a geographic location. So it has a latitude and a longitude associated with it. And then it might have some different type of geometry. It's a line, it's a point, it's a polygon. We even work with 3-dimensional data from time to time, including elevational data that's collected from aerial platforms such as drones. So we take all that data, we put it into a computer software, and then we can manipulate it and use it to help us manage our resources and answer research questions, and also to educate people. It's a very effective tool. It's one of my favorite things that I do at the reserve, working with GIS data. Okay, next on our list, habitat and species restoration. So I talked about the New England cottontail rabbit. Here it is. It's really adorable. Who wouldn't want to conserve this little bunny? Now, these guys are not actually endangered, but they're a priority species for U.S. Fish and Wildlife Service and for the Natural Resource Conservation Service. And they're being, there's a lot of money going into their restoration and their management. The reserve is a great site for them because we have early successional habitat, because our site was historically farmed, and most of the reserve at one point was probably completely cut. So all of the forests that you see when you come visit us are probably only 60, 70, maybe 100 years old in some places. So, and this species would have naturally been present in areas along our coasts that would have been naturally shrublands, but those areas were easily developed over the years. And so gradually all of the habitat for this species has been sort of gobbled up by development. And now they really require human intervention in order to hang on. So we're actively managing areas on our reserve for New England cottontail rabbit because they can't really do well. They're not forest animals. They're not estuarine animals. They really need that early successional habitat, fields that are converting to forest with smaller tree species and shrubs. And I've never personally seen one of these in the field. They're very elusive, but we have biologists with U.S. Fish and Wildlife Service that are here all summer tracking these animals, and winter for that matter, using radio collars. I think you can even see a radio collar on this particular rabbit. We have a telemetry system set up at the reserve that's actively tracking the location of our collared rabbits. And the technicians, the biologists, use those radio collars to try to locate these animals. When we find a radio collar that hasn't moved for a while, we know that that's a rabbit that's probably that probably hasn't made it. And sometimes these radio collars pick up and leave, and that's probably a rabbit that's been caught by a raptor, like a hawk or an osprey or something. So, but they're doing pretty well now. They're naturally reproducing, so we have a population that hasn't just been transplanted here, but they're actually producing young that are surviving from one year to the next. So that's really good news. We're very happy about that. And I'm not sure what the next couple years have in store for management. Now that we've completed our New England cottontail plan for the most part, we're going to move into the phase of just kind of maintaining what we have here. And of course, we're going to be responding to the needs of our partners. Maine Inland Fisheries and Wildlife, I should actually say, is another major partner on the New England Cottontail Project. So our state and federal resource agencies will be working with us to continue managing for this species after our restoration plan is complete. Okay, back to that list. Aquatic organism passage. I'll just check the time here. We're getting close to the end, so I'll just kind of go through this last part real quick, and then if you have any questions, we can discuss those. So what I started doing when I first got to the reserve, what I did for a long time, was monitor fish species in our estuaries and our rivers. This is a rainbow smelt, which is a diadromous species. That's a fish that migrates from the ocean into fresh water. Or excuse me, this is an anadromous species. So they migrate from the ocean into fresh water to lay their eggs and spawn, and then they return to the ocean. We also have one species of what's called catadromous fish, and that's the American eel. American eels live in our freshwater rivers and streams, and they might migrate to the ocean all the way down to the Sargasso Sea near Bermuda to spawn there in the wild. And then the young return to our rivers every year. You've probably heard of them. They're called elvers, highly sought after in Maine, which I think is the last state that actually allows a commercial harvest of juvenile eels. And so I've been monitoring these species for about 11 years. And so we've caught all kinds of different fish in our estuaries. We've done electrofishing in our rivers and streams. We monitor environmental quality in the habitat to make sure that it's conducive for the life cycle needs of these fish. And one of the major challenges for migratory fish are the man-made barriers that have been put on our rivers and streams, where we have stream crossings at culverts and bridges, or early on dams. And we still have lots and lots of dams. We have thousands and thousands of road crossings throughout the state. It's a major problem for these fish, and their historic habitat, their access to their historic habitat has been greatly reduced over the last 400 years. So this is an issue that's not unique to us here in Southern Maine. It's something that we work actively with partners throughout the state on. And we've done a number of different projects over the years. One of the ones that we're most proud of is the restoration of a fish ladder at the Kennebunkport and Wells Water District here on the treatment plant here on Route 1. Behind that big brick building on Route 1, there is a dam, and they use this impoundment as a settling pond so that when they're bringing water into their system, it's not quite as full of sediment and organic debris. And so the dam's very important for their operations, but unfortunately, it creates a barrier for fish that need to get upstream. And not just migratory fish, but also resident fish. So we have a really robust population of eastern brook trout in Branch Brook. And those fish sometimes will drop down over the dam. And without a way to get them back over, they wouldn't be able to access the tributary streams further up where they lay their eggs and reproduce. So We want to make sure that the habitat upstream and downstream of this dam is connected for those species. And so this fishway was actually built in the early 1950s when the dam was originally raised to its current elevation. And at that time, it was being managed by the Maine Department of Inland, what do they call it? Oh, the Maine Department of Fish and Game or something like that. It's a predecessor of the current Inland Fisheries and Wildlife Department. But over time, it was not maintained. It was not being maintained by the Water District. And so in 2013, the Wells Reserve, along with a few other partners, got together to work with the Water District to rehab this fish ladder. And it was re-engineered by some engineers with Stantec engineering firm based out of Topsom to kind of improve the design a little bit, to make the steps up the ladder a little bit shallower so that fish could more easily navigate. And this is a photo from this spring after we did a little bit of maintenance on it. It gets mucked up by beaver that live in the impoundment. They don't like the flowing water and they like to clog it up with mud and sticks. So we got in there with an excavator. The Water District crew got in there and cleaned it out. I actually got in there with a shovel and mucked out the part that the excavator couldn't get to. It is not fun digging through mud that is full of sticks. You can't stick a shovel into that stuff. So that's my manual labor for the spring, and hopefully I'll be recovered by next year when I have to do it all over again. But when we first installed this fish ladder in 2013, we had about 4 years of monitoring. We found 4 species of fish using the fish ladder. And so we're very happy with the way it's performing, and it looks great with all this water running through it. So I'm just going to stop there. There's lots more to talk about. This is a shot of a salt marsh up in Cape Elizabeth, actually, that we're working there to try to replace this culvert, not for fish passage, but to reconnect tidal flow and restore the salt marsh there. So I'm going to leave it there. I can't believe I was actually able to fill up a whole hour with talking, but I guess that's the way it goes. I'm going to stop sharing and come back on the screen. And just want to say thank you very much to all of you for coming and hearing this presentation today. I hope you learned something, and I hope it was interesting. If you have any questions, I'd be happy to stay on the line and talk about those now. Or you can feel free to follow up with me on my email address, which was on that last slide that I've already cut away from, but it's also located on our website. Okay.
Thanks, Jake. Looks like, yeah, Chris had to jump to another call. So Bob and Tanya, do you have any questions for Jake? Oh, Tanya, you're muted.
Okay. Am I with you now?
Yeah.
Yeah.
Okay. When he was establishing early on the baseline for all of this, I was wondering if there were any surprises or any changes in direction based on the baseline that they established.
For the eco-acoustic
monitoring?
Yes.
Yes.
Yeah, that's a good question. I think we're actually a little bit stuck right now with this project because we've collected a lot of data, and these audio files are really big, so they're very hard to work with. So I don't know if you've ever, tried to load a really big photo on your computer. Sometimes it takes the computer a while to bring it up. So we're talking about gigabytes of data that we're trying to deal with, and when you're running statistical analysis on that much data, you essentially you get the analysis started and then it cranks for a day or two, and then you get your result, and then you have to figure out what to do with it. So from what I understand, we're still basically working up the data, and we haven't really had enough time that we've been detecting a noticeable amount of change. I wish that Sue were here, because she could probably answer that question better than I can, because it's not a project that I'm overseeing. But essentially, that's the idea, is that over time, we should be able to collect this data. Probably we're not going to do it every year, just because, like I said, it really, the data storage becomes a big issue for us, and we have to have big dedicated hard drives to keep all this data on, and we need backups of those hard drives. So it really becomes cumbersome. So we'll probably revisit this every 5 years or so. And so we'll probably have more to say on that in the next couple of years. I think we started that project maybe 3 years ago. So we're still very much in the data collection phase. We may have some early results, and unfortunately I don't have those to share with you right now. But if you want to follow up with me, I'd be happy to put you in touch with Sue or Jason Goldstein, who is our research coordinator, and he might have some better answers for you.
Right, right.
I think
Thank you.
there may also keep an eye on our calendar, because there may actually be some eco-acoustic program type stuff in the future. I'm sure we've done it in the past, so we'll probably have it again in the future.
Good. Thank you.
You're welcome.
Jacob, in one of those last slides, you were talking about the fish ladder that you were working on. You said you had 4 different species of fish going up through that. What are the 4 species you had?
Yeah, we had the diaderma species that we had were eastern brook trout, sea lamprey, and we had 1 alewife.
Okay.
And actually it's 5 species. We had, and then we had brown trout, which are non-native. They're stocked by the state for recreation, though they're not stocked in Branch Brook. So that was kind of interesting to see them migrating upstream there. And then white sucker is the other species that we were getting. And suckers are kind of a cool fish. They're native. They're a cold water species, and they get big enough that they can actually navigate a fish ladder. We're really excited about the sea lamprey. And actually, if you got another second here, folks, I'll share one other thing with you. Oh shoot! Well, give me just a second here. So when I was mucking out the fish ladder, one of the things that I observed was a whole bunch of juvenile sea lamprey wriggling around in the mud. And I mean, they were just all over the place. I'm sorry, I don't have the video queued up. I would share it with you, but we did a project. So we restored the fish ladder in 2013. We monitored sea lamprey migrating upstream to spawn, but we also did another project further up near the Wells Barrens on Water District land that's adjacent to the TNC property there, Nature Conservancy. And that site was an old dry laid stone abutment bridge. It was that's now part of a trail system, and it's on the snowmobile trail up there. And over the years, the abutment's been eroding, and a lot of those stones had been falling into the stream and had essentially blocked it up. So, and then all the kinds of sticks and sand had built up on the upstream side, and so it was a fish passage barrier. So that we had a project where we brought in a guy from an organization called Project Share, which is actually in down East Maine, and they're primarily focused on salmon habitat. But one of the special things they do is they use this equipment called a grip hoist. It's essentially a really big winch, and they take it to remote locations where you can't bring in you can't bring in equipment like an excavator or a crane, and you essentially you put up a cable, and you run a pulley on this cable, and you use nylon webbing, high strength webbing. And so you will, kind of wrench these rocks onto these web nets. And then as you tighten this cable, it's on a slight, uphill or downhill slope. And so as it becomes taut, it lifts the pulley and the rock up off the stream bed, and then you can pull it on the pulley out of the stream and then place it on the stream bank. So we had this great project. We were in there for 2 days. We pulled out all these stones. And the next day we came back and we looked in the upstream area, which had been a big pool and had now drained out. And we found all kinds of these little juvenile sea lampreys wriggling all over the place. So we knew that sea lamprey were still getting upstream there, but that was a good sign, because that they're actively reproducing in the system. So we thought, well, geez, this is going to be a really good thing for this species. And sure enough, so the last time I really got in there and dug out that fish ladder was probably 4 or 5 years ago, and I didn't see all kinds of little sea lampreys wriggling around everywhere. This time they were absolutely everywhere. So that's a great sign to us that those fish are responding to this restoration, and it's really exciting.
Yeah, that's pretty cool. Thanks.